All right, hey everybody. So today we are going to look at section 3.5, which is continuing solving our trig equations and just solving more than we did yesterday. So we're going to start by continuing to look at factoring. All right? So if we look at our first example here, what you should notice is that we now have two different trig functions. Instead of having an equation with all of one trig function in it, I now have an equation with both cotangent and cosine. Okay? I could manipulate this if I wanted to and take it down to sine and cosine, but if we try to reduce these expressions on either side, I'm still going to only be able to get it down to sine and cosine. I'm not going to be able to get it down to one singular trig function. Okay? So what we're going to do here is we are going to start by looking and seeing if there's a way that I can factor things out. And to do that, I want this to be set equal to 0. So what we're going to have here is we're going to have the cotangent of x times cosine squared of x. And I'm going to subtract 2 times the cotangent of x from both sides so that I can see that this is equal to 0. Now, what you should notice is that we have a cotangent of x here and a cotangent of x here. So we did this when we were simplifying all of those expressions already, is where we factored out that cotangent. So I'm going to get the cotangent of x times the cosine squared of x minus 2 is equal to 0. So now each piece here has one singular trig function to it. So we're going to set the cotangent of x equal to 0 and the cosine squared of x minus 2 equal to 0. Okay, we're going to add 2 to both sides, so we're going to get the cosine squared of x equals 2. And then from there, we're going to square root both sides. So I get the cosine of x is equal to the square root of 2. All right, so we are going to start over here with our cotangent of x. So remember that cotangent is the reciprocal of tangent. So if I have a 0 in the numerator, I want my tangent to have a 0 in the denominator. So where we're looking on the unit circle is where my tangent function is undefined. Okay, that is where my cotangent is 0. So if we look at our unit circle and we find where cotangent is, or excuse me, where tangent is undefined, we will see that that is at pi over 2 and 3 pi over 2. All right? Now, let's come over here to cosine of x equals the square root of 2. And actually, it would be plus or minus. Let's not forget that. Okay. So when I square root this, and I get plus or minus the square root of 2, what's important to realize is that the square root of 2 is not on our unit circle, right? So if I were to try to solve this for x, we would take the inverse of both sides. So I would do the cosine inverse, and let's just pick positive square root of 2 for right now. If you try to put this in your calculator, you should get an error message. Okay, the reason being, this is over 1, right? Cosine is adjacent over hypotenuse. And I want you to think, are you allowed to have a hypotenuse that is shorter than your legs? And no, okay? So anytime your sine or cosine is greater than 1, we know that there's going to be no solution for that part of my equation. So my only solution is my solutions for the cotangent. All right? All right, so let's take a look at another one. All right, what we see here is I have, again, two trig functions in one equation, and I have secant squared of x minus 2 times the tangent of x is going to be equal to 4. So as I'm looking at this, again, if I try to take this down to sine and cosine, there is no simplification that is going to get me down to one single trig function. Okay? I cannot factor anything out here. But what I should remember is that I have Pythagorean identities. And in one equation, I have both secant squared and tangent squared. So anytime you see a secant squared or a tangent squared in the same equation, then we want to look at trying to replace one of those squareds with an identity, so that way we can have all one trig function. So what I'm going to do is I'm going to take this secant squared and I'm going to replace it with the tangent squared of x plus 1. And then I'm going to continue my minus 2 tangent of x. And then we're going to subtract 4 from both sides so that we can set this equal to 0. All right, again, guys, I'm going to make my life simple here by saying, all right, the tangent of x is going to be equal to t. So that way I can do t squared minus 2t, and then plus 1 and minus 4 is going to be minus 3, equal to 0. All right, from here, since my a value is 1, this is an easy one to come up with my factors for. I'm looking for factors of negative 3 that are going to add to negative 2, which is going to give me a negative 3 and a positive 1. All right, so then from here, we are going to set each of these equal to 0. So I'm going to do t minus 3 equals 0. And t plus 1 equals 0. So let's go ahead and put my tangent function back in. I'm going to get the tangent of x is equal to, adding 3 to both sides, is going to be equal to 3. And the tangent of x is going to equal negative 1. Okay? So let's start over here with the tangent of x equals negative 1. Okay? We're going to look at our unit circle and find anywhere we see that our tangent value is negative 1. Okay, and we should see that we have 3 pi over 4 and 7 pi over 4. Okay, next we're going to come over here and look at this. The tangent of x is equal to 3. So what we should realize is that 3 is not a tangent value anywhere on our unit circle. Okay? But just because it's not on the unit circle doesn't necessarily mean that it doesn't exist. So what we want to do is check and see, all right, let's take the inverse. So our tangent inverse of 3 is going to give us 1.249. A reminder that we have been working with degrees frequently lately. Please make sure your calculators are back to radians. To put your calculators in radians, click on mode. Okay? Now, there's one last thing with tangent. Remember, we were talking about how if I'm looking at tangent on my unit circle, if I have a number over here, I know that the tangent value is the same on the other side. All the tangent values in quadrant 1 go across your diagonal to have a matching tangent value in quadrant 3, because 1 and 3 are both positive. So this right here is going to be my value of tangent in quadrant 1. But I also need to get the value of the tangent in quadrant 3. Remember that these are pi apart. So we're going to add pi to this to get that my x value is also going to be equal to 4.391. Please go to at least 3 decimal places and get in that really good habit. All right? So now my x values are 3 pi over 4, 7 pi over 4, 1.249, and 4.391. Okay, so again, it is important to remember that your inverse function is only going to give you the information in quadrant 1. So if you have something matching in another quadrant, you need to figure out what that is. All right? And guys, please do keep in mind that we do only have 4 answer choices because if we look back up here, our interval is between 0 and 2 pi. All right? So let's go ahead and look at another example. All right, when I look here, I see sine squared, sine, and cosine squared. You should automatically be thinking of that Pythagorean triple with sine squared plus cosine squared equals 1. So look and see like which one, take a second to think, which one does it make more sense to substitute in for? Does it make more sense to substitute in for sine squared? Or does it make more sense to substitute in for cosine squared? So yes, it makes more sense to plug in for cosine squared, because if we plug in over here, I'm going to have a cosine, a sine, and a cosine squared, and that's not going to help anybody. So we're going to take our sine squared here, minus sine x, whoop, I don't know why I wrote 2, plus 1, and then we're going to replace my cosine squared of x with 1 minus sine squared. Okay? And that is my Pythagorean identity. Alright, so I'm going to make life easy here and change my sine of x to s. So I'm going to get s squared minus s plus 1 equals 1 minus s squared. If I subtract 1 from both sides, these are going to zero out. And then we're going to add s squared to both sides. So I'm going to get 2s squared minus s equals 0. Okay, from here we're going to factor out an s and get 2s minus 1. And then again, we're going to set each piece equal to 0. So I'm going to go ahead and switch this one to sine. And if I take this back to sine, I'm going to add 1 to both sides, then divide by 2. This gives me a 1/2 over here. So from here, we want to use our unit circle to find out which values are going to work for us. So we are going to take a look here at our unit circle and find where our angle measures are, where my sine value is 0. And one of the things that I want you guys to do is with this problem, because most of your problems in AP Calc are going to have a limit, we're going to go ahead and make this limited to 0 to 2 pi. So if you would add that interval in for me, and it's the same as the problem above. So if I want to know what sine values are 0, I should see that I get 0 and pi have sine values that are 0. Alright? And then we want to do the same thing where sine is 1/2. And I should see that my x values are pi over 6 and 5 pi over 6. Alright, so my x values are all 0, pi over 6, 5 pi over 6, and pi. Alright, let's go ahead then and take a look at our next problem. Now, what we want to look at here, and I don't want you to write this down, but kind of some of the things that we were talking about before. We know that cosecant is 1 over sine. I know cotangent is cosine over sine. If I combine these, I'm going to get 1 minus cosine over sine. None of those are squareds, so there's nothing that I can substitute in. Alright? So I'm still going to end up with 2 trig functions. So doing this does not help me. Alright? So what we can do in this situation is, number one, notice that we have both cosecant and cotangent. And I do have a Pythagorean identity that includes both cosecant squared and cotangent squared. So what we're going to end up doing is squaring both sides to get us there. However, we're going to take one step before we do that so that we don't make our lives miserable for ourselves. All right? So a way to keep our life a little bit easier is to take all of one trig function and put it on one side of your equation, all of your other trig functions and put it on your other side. So I'm going to leave cosecant of x over here, and I'm going to add cotangent to both sides. So now what we're going to do is we're going to go ahead and square both sides of the equation. This is going to give us cosecant squared of x. Now, a shortcut over here, guys. Remember that when we do 1 plus cotangent squared, this is 1 plus cotangent times 1 plus cotangent, and we are either distributing throughout the whole thing, okay, or we can take a shortcut called square double square. Okay, the way the square double square works is you square your first term, so 1 times 1 is 1. Then we're going to double the product. So we're multiplying 1 times cotangent, which is just cotangent, and then we're going to double it. So it's 2 cotangent. And then we're going to square the last term to get cotangent squared. Okay, essentially that double here, remember that's the inside piece and the outside piece. It's 1 times cotangent plus 1 times cotangent, which is the 2 cotangent. Okay, it's doing the same thing that you would get over here. Alright, so now we should see that I have cosecant squared over here by itself, which I can replace with my identity so that I have all cotangent. So cosecant squared is cotangent squared plus 1. And then we're going to leave this the same over here. So now I have everything in one trig function. So again, I'm going to go ahead and make my life easier by saying that I'm going to make cotangent be c. So this is c squared plus 1 equals 1 plus 2c plus c squared. Alright, I'm going to subtract c squared from both sides. These are going to zero out. I'm going to subtract 1 from both sides. These are going to zero out. So I'm going to be left with 0 is equal to 2c. Divide both sides by 2. I'm going to get 0, and I'm going to go ahead and put my cotangent back in. Now, we did this earlier. Remember, if 0 is in the numerator, my tangent function is going to have 0 in the denominator. So on my unit circle, I am looking for where my tangent is undefined. And those angle measures are pi over 2 and 3 pi over 2. Now, here's a big problem that we have when we square both sides. We go from something that's not squared to something that is. What happens when we square negatives? They become positive, right? So I could actually, by squaring things, have a solution that does not work in the original equation. It's an extraneous solution. So before we say, hey, yay, I have my answers, we always need to check for extraneous solutions. All right, and we do that by plugging those back into the original equation. All right, so let's start with pi over 2, and we're going to get the cosecant of pi over 2 minus the cotangent at pi over 2 should equal 1. So if we look at our unit circle, remember, cosecant is the reciprocal of sine. So sine at pi over 2 is 1. So if we take the reciprocal, it's still 1. All right. If I look at pi over 2, the cotangent, okay, the tangent is undefined, which means that the cotangent is 0. So I'm going to get 1 equals 1, which means this is a valid solution. Then I want to check my other possible angle measure. I'm going to look at the cosecant of 3 pi over 2 minus the cotangent at 3 pi over 2 and see if that equals 1. Well, I go and I look at my sine value at 3 pi over 2. It is negative 1, so the reciprocal is still negative 1. Okay, know that. Okay, and then we're going to look at 3 pi over 2 and recognize that the tangent value there is undefined, so the cotangent value there is 0. And I'm going to get negative 1 equals 1, which does not work. So my only solution here is that x is going to be pi over 2. And you can write this with the fancy brackets or not. Whenever there's only one solution, it's fine either way. Okay? Okay, so let's look at one more problem. All right, same thing's happening here. We have a sine on one side, a cosine on the other. I have no squareds, no way to replace it, and no way to make it the same. So we're going to start by squaring both sides. And I'm going to get sine squared over here. And 1 minus 2 cosine plus cosine squared over here. I'm going to go ahead and take this sine squared and replace it with 1 minus cosine squared, since I have 2 cosines on the other side. And this is going to be 1 minus 2 cosine of x plus cosine squared of x over here. So we're going to make life easy and set cosine x equal to c. So over on this side, I'm going to get 1 minus c squared. And over here, I'm going to get 1 minus 2c plus c squared. So we are going to subtract 1 from both sides. These will zero out. And then we're going to add c squared to both sides. So I'm going to get 0 equals negative 2c plus c squared, or plus 2c squared, excuse me. All right, we are going to, from here, factor out a 2c. So this is going to give me negative 1 plus c. And I'm going to set each one equal to 0. So I'm going to get 0 equals 2c. And negative 1 plus c equals 0 as well. All right, divide both sides by 0. If I take this back to cosine, I'm going to get the cosine of x is equal to 0 when we divide both sides by 2. Add 1 to both sides, I'm going to get the cosine of x equals 1. So we're finding our values where the cosine is 0, and that is going to be pi over 2 and 3 pi over 2. And where my cosine is 1 is x equals 0. So then we're going to go ahead and check for extraneous solutions. All right, and I'm going to take these three values and plug them back into the original equation. So I'm going to start with pi over 2 and say sine of pi over 2. Does that equal 1 minus the cosine of pi over 2? The sine of pi over 2 is 1, and the cosine at pi over 2 is 0, so I'm going to get 1 equals 1, and that's good. So then we're going to check 3 pi over 2, so I'm going to do the same thing, but with 3 pi over 2, and 1 minus the cosine of 3 pi over 2. And the sine at 3 pi over 2 is negative 1, and the cosine again is 0. So I'm going to have negative 1 equals 1, which is not true. So this is not a valid solution. And then we're going to check the last one, which is 0. And I'm going to get the sine of 0 is 0. And the cosine of 0 is 1. So 1 minus 1 is 0. So this is also a valid solution. All right, so my valid solutions that I have are pi over 2 and 0.